All right, let's dive right in. Today, we're going to decode a kind of secret language. It's a language that's written into pretty much everything around us, from the wings of a butterfly all the way up to the fundamental laws of the universe itself. So let's get into the absolutely fascinating world of symmetry.
So, what do these three things, a butterfly, a snowflake, and a starfish, all have in common? I know, it sounds like the beginning of a riddle, right? But the answer is a single, incredibly powerful idea. It's this hidden thread that connects the structure of our own bodies to the shape of entire galaxies. And that answer is, of course, symmetry.
So what even is symmetry when you get right down to it? Well, probably the most elegant definition is this. It's an object's immunity to change. Now, what that means is, if you can do something to an object, like flip it or turn it or even slide it, and it looks exactly the same as when you started, then that object has symmetry. It's that simple. Okay, so this whole universal language is actually built from just a few really basic words. The technical term for them is isometries, which is just a fancy way of saying transformations that don't change an object's size or shape. Let's break down the three core types. First up is the one we all remember from elementary school, reflectional symmetry. You've probably heard it called by its other name, mirror symmetry.
The concept itself is incredibly intuitive. Just picture folding a piece of paper in half. If the two halves line up perfectly, boom, you found an axis of symmetry. A butterfly's wings are the classic example, right? But this is where it starts to get cool. A simple square has 4 of these axes, and a perfect circle, it has an infinite number of them running through its center. Okay, let's move on to our next building block and see how this all connects. Rotational symmetry. This is the symmetry of spinning.
So the key idea here is that you can turn an object and it remains unchanged. A pinwheel is a perfect example. Give it a quarter turn and it looks identical. A 5-armed starfish looks exactly the same after being rotated by just 1/5 of a full circle. And something like a Triskelion has what we call threefold symmetry. You can turn it 3 times within 1 full rotation and it's going to look identical at each step. And that brings us to our final basic building block, translational symmetry. This one is all about repetition in a straight line. This is the symmetry of patterns. If you take a strip of wallpaper and just slide it, the pattern matches up perfectly. Same thing with tiles on a floor. This even gets into the kind of mind-bending idea of infinity. Imagine a line of footprints that just stretches on forever. If you were to slide that entire line over so that one footprint lands exactly where the next one was, the infinite line would look completely unchanged. Okay, so let's do a quick recap. Reflectional is a flip, like a butterfly. Rotational is a turn, like a pinwheel. And translational is a slide, like a repeating pattern of footprints. Flip, turn, and slide. These are our 3 core words in the language of symmetry. But this is where it gets really beautiful. Just like with any language, you can combine these simple words to form more complex senses and to create these incredibly intricate patterns. So our first combination is one we all perform every single day without even thinking about it. It's called glide reflection, and it is, quite literally, the symmetry of walking. Seriously, look down at your feet next time you're walking. Your left footprint is a mirror image of your right. But to get from your left print to your right print, you're actually doing 2 things at once. You reflect the foot, and you translate it or glide it forward. A reflection plus a translation. That is a glide reflection, and it's what creates that perfect alternating pattern of our footsteps. Okay, now let's combine 2 other symmetries to create something that is truly fundamental to life itself. Let's talk about helical symmetry. Helical symmetry is what you get when you rotate an object and translate it forward at the exact same time. Think about walking up a spiral staircase. With every single step, you are turning and you are moving up. But the most profound example of this has got to be the double helix structure of DNA. It twists and it rises. And what's amazing is that it has a non-repeating symmetry. It takes about 10.5 base pairs to make 1 full turn. This complex symmetry is literally the blueprint for all known life.
So far, we've only been talking about symmetries that keep objects the same size. But what if we introduce a whole new kind of transformation? What if we talk about symmetry across different scales? Well, this brings us into the totally mind-bending world of fractals.
The mathematician Benoit Mandelbrot gave us this beautiful and simple way to think about it. He said, a fractal is basically a shape made of parts that are similar to the whole thing in some way. A tiny piece looks just like the whole thing, only smaller. This property is called scale symmetry. It means that whether you're looking at an object from a satellite or through a microscope,
The fundamental patterns of its structure just keep showing up, over and over again.
And let me tell you, nature absolutely loves fractals. A single frond of a fern looks like a miniature version of the entire plant. The jagged path of a lightning bolt is filled with smaller, similar jagged paths. Even a coastline, when you zoom in, reveals smaller bays and coves that echo the shape of the larger one. It's symmetry that repeats not through space, but through magnification. Now at this point, you might be thinking that symmetry is just about making pretty patterns. But the truth is much, much deeper than that. Symmetry is one of the most fundamental organizing principles of our entire reality. This right here is one of the most powerful statements in all of science. It means that the rules that govern how the universe works, they don't change based on where you are, or which way you're facing, or when you're doing an experiment. They are immune to change. In other words, they are symmetrical. And this leads us to one of the most beautiful ideas in physics, Noether's theorem. Put simply, it states that for every type of symmetry you find in the laws of nature, there is a corresponding quantity that must be conserved, something that cannot be created or destroyed. So symmetry isn't just about aesthetics, it's the reason for the most fundamental laws we know.
Let's look at a really concrete example. The laws of physics have rotational symmetry. It doesn't matter if you do an experiment facing north or facing east. Gravity works the same way. Well, because of that symmetry, Noether's theorem tells us that a specific quantity has to be conserved, angular momentum. It is the very reason a spinning ice skater speeds up when they pull their arms in. This isn't just some coincidence, it's a direct consequence of symmetry. So we end with this thought. If the rules that write the story of our cosmos are themselves deeply symmetrical, what does that say about the cosmos itself? Is the universe, in its grandest and most fundamental form, the ultimate expression of symmetry? From a simple butterfly's wings all the way to the very fabric of reality, that's the power of this hidden language. Thanks for watching.